All right, we're gonna find the vertex of the function f of x equals x squared minus 2x plus 1. That is the parabola. We have a parabola, something like this or something like this. Now, we want to find the vertex, right? How do we find the vertex? Absolutely easy. We're going to use the same little formula for the x coordinate. Remember, since this is a vertex, we know it has coordinates x and y. We know that. So with the help of our little formula here, we can find the value of the x coordinate, this one over here. And from there, we can do some other things to find the value of y. So let's begin. The value of our x coordinate, and I like to call it like this, the vertex x, I like to call it like that. Some other books call it in some other ways. It is exactly the same. It's the same formula, right? Will be the value of negative b. But what is negative b? All right. In our function, we have a value of negative b. The value of b, I'm sorry, I'm saying negative b, but we need a value of b, right? So in case you are having difficulties here locating the values of a, b, and c, this is what I recommend. I recommend you write them down before you do the exercise. So the coefficient a, the value of a, will be the coefficient of x squared, which in this case, since there's nothing, then that will be a 1, right? The 1 will be implied. Beautiful. Now, the value of b. All right, so the value of b is the coefficient of x, meaning the number that accompanies, the number that goes with x, which is exactly negative 2. Don't forget about the signs. Signs are also parts of the number. And last but not least, the constant value, the one that is not coefficient of anything. The number alone, without any variables. 1 in this case. Now, different functions will have different values. So make sure you know how to find the values a, b, and c, right? Now that we have our values, now we can find the vertex. And all we have to do is plug in all these values in the formula. So the formula was negative b. So we have our negative for the formula, and now we're going to plug in the value of b, which is negative 2. We have double negatives because b is negative 2, and the formula has one negative. So it makes sense we have the negative of the formula and the negative of the value, double negative. Also, the formula says negative b will be over 2 times a. So we have 2 times and then the value of a, which in this case will be 1. All right. What will be then the value of x? All right, negative and negative will make it so that 2 is positive. And we have 2 times 1, which is 2 as well. Meaning the value of the x coordinate will be just 1. Okay, congratulations. And if you want to, you can already write it in your answer. The vertex of the formula is 1 comma something. We don't know yet, but we know it is 1 comma something. Okay, so we know half of the answer, half, just by using our formula. That is why that formula is so strong. Because with that formula, you don't need anything else, really. All right, from here, let's find the value of y. But how do you do that? Absolutely simple. We want to evaluate here. We want to evaluate f of the value that we just got. In this case, f of 1. In this case, we did f of 0 because the value of x was was 0. But in our case, in our vertex, the value of x is 1. So we want to evaluate f of 1. What that means is take the original formula, the original function, f of x, and instead of x, wherever you find an x, write down a 1. Plug in the number 1. That is what we're doing. We are replacing the value x for a 1 because that is the value x that we got. We got that x was 1. So from here, replace the values, right? So x squared will be 1 squared minus 2 times x, so 1, 2 times 1, and then plus 1. If you solve this thing, we will have as a result 1 squared, which is 1, minus 2 times 1, which is 2, all right, plus 1. This thing, if my calculations are not wrong, will be 0. Let's see. 1 minus 2, that is negative 1 plus 1, 0. Beautiful. So now we have the second part of our vertex. Remember, the vertex has coordinates x and y. It is a point. So we need to have two coordinates, x and y. And we had the 1 because of our formula. So now we have the second part of the vertex, 0. Meaning that the vertex of this function is at 1, 0. Now, we can double check this if you want to. All we need to use is some sort of graphing calculator or software, some sort of graphing calculator. Let me see if I can, yes, like this. All right. Beautiful. So from here, I can show you what would be the result if I graph the function x squared minus 2x plus 1. Look, x squared will be x squared, look, x squared, right? Minus 2x, right? Plus 1, right? So plus 1. And like that, I just finished the graph. And look, we have our function. We have it as a beautiful parabola that opens up. We know that because the coefficient of x squared was positive, so it opens up, right? We also know the y-intercept is this point, 0,1. That would be the y-intercept because the value of c was 1. But we also know the vertex. The vertex will be 1, 0 because look at that. It is the lowest point in the parabola. 1, 0. The exactly same one that we had from our calculations, 1, 0. Look at that, guys. Isn't this thing beautiful? All right. All right, so that is how you do it, all right? That is exactly how you do it. Now, remember, if you have any more doubts, you can always ask me, and I am here to help you guys. But this exercise was pretty cute. Pretty cute.
Thanks, mister. So
With pleasure, all right? With pleasure. All right, let me see in the chat, maybe some more people have questions. Tefa Cabrera, profe, para los ejercicios 31 en adelante, ¿cómo se encuentra el range de una función cuadrática? I'll explain it in a minute. Let me change to the board there. I'll explain it in a minute, all right? And then Luna Campo, mister, can you do the number 31, please? Absolutely. Absolutely, all right. Let me erase all of this and I'll show you. All right, so I feel like this range and all of that is a lot better taught with an example. It's a lot easier to teach these topics with an example. So I'm gonna do number 31 because with number 31 I can show you what is an axis of symmetry, what is a range, all of that. I can show you all of that with the number 31. So I'm gonna change back to the book real quick to write down question number 31, and then and then I'll explain it to you. All right, question number 31 is f of x equals x squared plus 2x. All right, f of x equals x squared plus 2x. X squared plus 2x. Beautiful. All right. I didn't read the question, sorry. In numbers 31 to 46, graph each quadratic function by determining whether its graph opens up or down and by finding its vertex, axis of symmetry, y-intercept, x-intercept, if any, right? That is part A. And we also, part B, we need to determine the domain and range of the function. Also, the question C is determine where the function is increasing and where it is decreasing. Beautiful. Beautiful. This is a great question. All right. Okay, so let's work this thing up. let's jump into the graph. So section A, we need to graph or sketch rather this function. I like to say it, we are going to do a sketch because I feel like graphing this function is a lot different than doing a sketch, right? For us to be able to graph this, we'll have to be extremely perfect with our writing, with our hand and our drawing, and that would be difficult. I feel like the only possibility for a graph to be perfect is using a software, using the one that you just saw, or using any type of calculator. But if we want to do it a hand, then we are going to have issues. We are going to have difficulties because we are humans. So I don't feel like we're doing a graph. I feel like we're doing a sketch. The better the sketch, the prettier the sketch, the better. But it is a sketch nonetheless. So let's try to do a sketch here. All right. So let's try to find our properties of the function. And from there, we can work on our drawing. So please, in the chat, if you are listening to my question, because I know some of you are working on some others, right? Does this function opens up or down? Let's see. All right. People are answering. And okay, thank you. Thank you for the people who opened the mic and said up. Thank you, guys. Thank you for all of you who answered. All right, so that question opens up. That function opens up. So we don't know exactly, but if we were to draw a Cartesian plane, we know it will be something like this, right? Now, we don't know exactly where is the vertex, where would be the intersection with the x-axis or the y-axis. We don't know. It could be something like this. It could be, there could be a lot of possibilities, something like this. There could be a lot of possibilities, right? But we know it opens up, and that gives us clues about our sketch, right? Beautiful. So we know it opens up. Let me just write it down here. Opens up. Beautiful. Now let's try to find the y-intercept. This is the shape, and now let's find the y-intercept. Now the y-intercept is the value of c of our function, right? The value of c. Now we have a value of a value of b, and a value of c. So please, in the chat, write down the value of c of our function. Okay. You guys, all right, you guys are really fast. All right, beautiful. The value of c is 0, meaning the y-intercept is 0. So now we know. For our function, if it opens up, we cannot have something like this. We can't. We cannot have something like this. We cannot have something like this. These are bad possibilities. Something like this is a bad possibility. We cannot have something like this because we know the y-intercept of our function is in the point 0. Now let's try to draw it prettier this time. I don't have access to a ruler, guys, so please don't judge me. If you have access to a ruler, go ahead and use it. All right. So this will be my Cartesian plane, and in here I will be writing down these pieces of information. Now the y-intercept we said was 0, so I know my function passes through exactly the origin in y, 0, and this will be x, right? Beautiful. We also know it opens up, so it could be something like this or it could be something like that. I don't know, but it opens up. Let's continue. Let's try to find more properties for our function. How about we find the vertex now? Let's try to find the vertex. Okay, for the vertex, we do have to write down some things. These two, the shape and the y-intercept, were the easiest because all you have to do is look at them. All you have to do is just look. You look at the value of a and then you look at the value of c. Those are the ones you want to start with because they are the easiest. But for the vertex, we're going to have to do some things, right? For the vertex, we are going to have to do some things. All right, the vertex. The vertex is a point that has coordinates x and y, right? But we know that the vertex can be found with our formula. The vertex is negative b over 2a, right? Now, if we replace the values of our function into the formula of the vertex, we will have negative b. All right, the value b of our function is 2, so we have negative 2. All of this over 2 times a, but the value of a of our function is 1. So negative 2 over 2 times 1. Meaning the value of x will be negative 2 over 2, which is negative 1. And now we have the x coordinate, negative 1. Beautiful. How do we find the y coordinate? Absolutely easy. Take the value that you just found and replace it in the function. Evaluate. So evaluating f of negative 1. We will have f of negative 1 will be x squared, so negative 1 squared, and make sure you write these ones with parentheses. The negatives have to go with parentheses. Otherwise, you're going to have something like this. Negative 1 squared. And this is absolutely different than negative 1, all of it squared. Why? Because of the order of operations. In this case, you have to do 1 square and then put a minus. But what I want to do is do the negative 1 square, right? So make sure you put parentheses. All right, continue. Plus 2 times x, which is 2 times negative 1. All right, this value will be negative 1 squared will be positive 1. And in here we have plus 2 times negative 1, which is negative 2. So negative 2. In other words, 1 minus 2 will be negative 2 as well. Look at that. What a coincidence. The value of x and the value of y are both negative 1s. That is a coincidence, right? The other exercises that we have done for the vertex give us different values of x and y. In this case, we have negative 1 and negative 1. What that means is that our function, the vertex of our function, has to go in x negative 1 and in y negative 1. So exactly at this point. This will be the vertex of our function. So now we know some information, and now we can kind of do a drawing in our heads for the function, because we can do something like this. If it opens up, it has to go from here, then pass through the origin and up, right? Meaning it would have to go something like that as well. All right. From here, we can for sure do a sketch of our graph. We can, but we can make it even better by finding more properties of the function. We can find another property that is called the roots, the zeros, the x-intercepts of the function. Here, we found the y-intercept, and that was the easy, but the x-intercept is easy as well, but it takes us a little bit more time, right? Let me show you right now. For the x-intercepts, right? But the x-intercept, it could be 1, or it could be 2, or there could be no x-intercepts. Now, if we draw the graph real quick, if we do a sketch real quick, we have something like this. Wait, and then wait, something like that, right? We will have something like that. Now, it is horrible. It is a sketch, but it is kind of the shape that we will have our answer. Because we are looking for a parabola that begins, has its vertex at negative 1, negative 1, and passes through the point 0 in y. So it will have to be something like that. But how can we make sure this is the real solution, right? We find the x-intercepts. Now we know we have one intercept here. This is one of the intercepts because that little point is also in x. So that counts as both y-intercept and x-intercept. This is a rare case. A rare case. This almost never happens. But in this case, we have that x-intercept. So we know one of the solutions. But can we find the other one solution, the other one? Here's another one, Here's another one. Those are two x-intercepts. We find one, but can we find the other one? Yes. Yes, we can. For that, we are going to use the quadratic formula. Of course, there are a ton of ways of finding this. A ton of ways. Maybe you at home are thinking on a way to find this other point without having to use the formula. And that is okay. You could factorize this. That is okay. Or you can recognize the distance between the vertex to the x-intercept and then move that back to the left. That's another possibility. I'm going to show it with the quadratic formula just in case we want to use that in a different exercise. Okay, so our quadratic formula, if you don't remember it, I'm going to write it to you right now. It'll be negative b plus or minus, we have a square root, and inside the square root will be b squared minus 4 times ac, and all of that over 2 times a, right? All we have to do is replace the values of a, b, and c. We replace those values, solve for x, and we should have the two answers, 0 and something else that we don't know. 0 and something. We know one of the answers is 0 because we already said it. That was one of the x-intercepts. So we are kind of cheating. We know already which will be one of the answers. We already know that. All right, let's do this exercise absolutely fast. We will have x, and on top of x, we will have negative b, which is negative 2, plus or minus the square root of 2 squared, which is 4. Again, I am saying b squared, and since b is 2, I did already a 4. 2 squared, right? Minus 4 times a times c. Okay, so 4 times 1 times c. But c is 0, right? All of that over the value of 2 times a, which is 1. If we solve this real fast, we will have negative 2 plus or minus the square root of what? How much is this thing inside? Okay, 4 times 1 is 4 times 0 is 0. Meaning that here we have 4 minus 0. So this is the square root of 4. But how much is the square root of 4? Well, that thing is 2. So we have negative 2 plus or minus negative 2 over 2 as well. 2 times 1, 2. From here, we split our equations, and we have 1 with the negative value and 1 with the positive value. So like this, and x equals negative 2 minus 2 over 2. A lot of 2's in here. From here, solve each one of these values, and we are going to find both. So x will be in here. Negative 2 plus 2 will be 0 over 2, which is 0. Yes?
El 4 es a la 2.
No. Look. Thank you for saying. Thank you for noticing. But no, look. Here, b is square, right? And ask yourself, please, what is the value of b? 2. So we have 2 squared, which is 4. Did you see? Better? Somebody?
Yes, mister. Thank you.
Yes.
Okay. All right. All right, let's continue. So we have our first value, x equals 0, which is the one we already knew. We knew from the start one of the x-intercepts was 0. So let me write it down here. We have the x-intercept of 0. But we also have another x-intercept, the one that we didn't know. And we're going to find it by solving this x. All right. So in here, x will be negative 1 minus negative 1. That is negative 4. Negative 4. Did I say negative 1? sorry, -2 minus -2. Sorry, -2 minus -2 will be -4, right? And all of that over 2. Now, if you simplify this, you will have that x equals -2 as well. A lot of negatives 2 in here. So we have our second value, which is -2. And it makes sense. Look, it makes sense. My drawing was off by a little bit, because the -2 is exactly here. The -2 is exactly there. Okay? So my drawing is off. That is why we call this an sketch, because maybe we don't draw it that perfectly, right? But the more properties we apply to our function, the better our graph will be. So again, we knew we have a y-intercept in here, right? We have a vertex in -1, -1. We also know it has two x-intercepts, 0 and -2, so exactly here. And now we can make a better estimation of our function, a better estimation. My function will be, starting from the vertex, I am going to graph up through each of the points and then kind of curving. If I did it to the left, to the right, sorry, I'm gonna do it to the left now. From the vertex and up and kind of curving. Now, as you can see, my function is not perfect. It is not. I am sure if I overlap this with the real function using any type of calculator or software, mine will look pretty awful. It will. And it will happen to you guys, because these properties are going to help us do a sketch, so an approximation of the function. But yeah, this is how, guys. All right, this is how you use the properties that I teach you. Now, there is one property that I did not use, and the property I did not use was the x of symmetry. We have the shape, the y-intercept, we have the vertex, and we have the x-intercept. But I did not use the axis of symmetry, right? And the reason why I did not use the axis of symmetry is because, one, we don't need it right now, and two, because right now you have to go do the quiz, right? So next class, guys, we're gonna continue with this same exercise, and I'm gonna show you what is the x of symmetry and how did you find the range, how did you find all those other things, all right? So guys, I'm gonna cut the video here, and please go do the quiz. Thank you, guys.